Units and measurement. This is the second topic in first POC, and in this units and measurements, the topics are covered are introduction to unit, the international system of units, measurement of length, measurement of mass, measurement of time, accuracy, precision of instrument and measurement, significant figures, dimensions of physical quantities, dimensional analysis and its applications, even dimensional formulae and dimensional equations. Coming to this lesson, we can just discuss regarding introduction. First, we will start with introduction to unit. So, what do you mean by unit? Especially whenever you go to shop, so if you want to purchase anything, like if you want to purchase oil, you'll ask, I need 1 liter of oil. They'll say liter, right? And if you need a rice, so you'll ask them, I need 1 kg of rice, isn't it? So what is this liter and kg? So here it's a unit. So mass is measured in terms of kg. So 1 kg of sugar, kg, kilogram. So mass you are measuring with kg, and oil you are measuring with liter, right? That is also one unit, right? Unit is internationally accepted reference standard to measure a physical quantity. Any physical quantity can be measured with a specified unit, and that unit is internationally accepted reference standard to measure a physical quantity, right? Example, rice measured in kg. So mass can be measured in terms of kg. Volume is measured in terms of liter. Even distance is measured in terms of meter, right? So what is the unit? Unit is internationally accepted reference standard to measure a physical quantity. Any physical quantity can be measured with the help of units, right? And in this units we have 2 types, and those 2 types of units we can discuss one by one. I can say that number of units is comparatively lesser than number of physical quantities. Means existing physical quantities are more, like mass, time, electric current. So as compared to these physical quantities, the units is less. Why? Because many physical quantities have same units. Means, for example, work is a physical quantity. Even energy is also a one physical quantity, but work can be measured in terms of joule. Even energy is also measured in joule. So work SI unit is joule, energy SI unit is joule. So the number of physical quantities, work and energy are physical quantities, but joule is a unit. So both quantities have the same unit. So I can say many physical quantities have same unit, so that number of units is lesser than number of physical quantities. Also, many physical quantities are due to combination of existing units. For example, I said we have a distance. Distance is measured in terms of meter, or displacement is also measured in terms of meter, and time is measured in terms of second. But velocity, coming to velocity, velocity is rate of change of displacement. In this velocity, we can write it as displacement by time. So displacement is measured in terms of meter, as well as time is measured in terms of second. So velocity, displacement by time, meter per second. So velocity SI unit is meter per second. Here we have derived it, velocity as a derived from the fundamental unit. So here I can say also Many physical quantities are due to combination of existing units. So meter is a existing unit, second is a existing unit because length is measured in terms of meter and time is measured in terms of second. So velocity is combination of units of length and mass. Velocity unit is meter per second and it is a derived unit because it is derived by taking two fundamental quantities, length and time, right? Therefore, number of units is comparatively lesser than number of physical quantities. You understood this, right? Units will be less and physical quantities will be more because we can derive some physical quantities from the fundamental units. Coming to types of units, we have two types of units. One is fundamental units or base units. Another one is derived units. First, we can discuss related to fundamental units. These units are based on which all the units are derived. These are the fundamental things to derive another things. So here these units are based on which of all the units are derived. Fundamental units. We have 7 fundamental units. We have 7 fundamental units. We have 7 fundamental units or base unit. In that, length, mass, time, electric current, temperature, amount of substance, luminous intensity. So these are the fundamental units. For this length is measured, length is related to distance and distance is measured in terms of meter. Mass is measured in terms of kilogram, so notation is kg. Time is measured in terms of second, notation is s. Electric current is measured in terms of ampere, that notation is A. Temperature is measured in terms of Kelvin, notation is K. Amount of substance is measured in terms of mole, that is representation MOL. Luminous intensity measured in terms of candela, that is CD. This is all about fundamental quantities. Just you need to remember we have 7 fundamental quantities and those 7 fundamental quantities can be measured in this way. Length, meter, mass, kg, time, second, electric current, ampere, temperature, Kelvin, amount of substance, mole, luminous intensity, candela. Yes, coming to derived units. Second type of units, derived units. These derived units are derived from fundamental units. So this derived, like I said you just now, velocity is derived unit. The velocity is derived with displacement by time. Displacement is measured in meter and time is measured in second. Those are fundamental quantities, right? So from those fundamental quantities, velocity is derived unit. So velocity can be measured in terms of meter per second. So derived units are derived from the fundamental units. Its origin is fundamental unit or base unit. Example, area. Area SI unit is what? Area formula we have length into breadth. So length is also measured in meter, breadth is also measured in meter, meter into meter, meter square. So area is measured in terms of meter square. Even volume, length into breadth into height. So meter into meter into meter, meter cube. So volume SI unit is meter cube. Velocity, just now we discussed, velocity displacement by time. So meter per second it is. Density is equal to mass by volume. So mass by volume. Mass is measured in terms of kg, volume is measured in terms of meter cube. So kg per meter cube. So fundamental units and derived units together we will call it as system of units. These completely we will call it as a system of units. So SI unit is a full form for SI is System International. Means it is accepted everywhere, globally accepted system for measurement. Right. SI units two types. One is a fundamental unit and one is a derived unit. 7 fundamental units are length, mass, time, electric current, temperature, amount of substance and luminous intensity. but derived units are remaining every unit, remaining all physical quantities are derived from the fundamental units. So derived units are derived from the fundamental units only. We will discuss in the next class.